The most repeated figure on AI coding productivity right now is 18% faster. That number comes from 10 developers, not 10,000, 10. And in February, the researchers who produced it announced they were rewriting the experiment that made it. Every speedup number is really a comparison, the same work done twice. Once with the tool, once without it, and both times measured. The second run is the hard one. Someone has to give up the tool on real work and let a clock run on them while they do it. When fewer people agree to that second run, the number does not break, it tilts. And it tilts the same way every time. METR ran exactly that design. The same developers, their own open source repositories, each issue randomly assigned to AI allowed or AI disallowed. 7 developers, 123 repositories, more than 800 tasks. The half working without AI was real, and it did produce a number. The problem is not that this half vanished. It is who stopped volunteering for it, and which tasks never got submitted to it. This is METR's page, and the heading is theirs. Wider adoption of AI has made it more difficult to measure task-level productivity. They call the result an unreliable signal and likely a bad proxy for the real productivity impact on these developers. Then comes the sentence that matters most. They believe their own estimate is likely a lower bound on the true effect. A growing share of developers declined to take part at all because taking part meant doing half their work without AI. Between 30 and 50% of those who did take part held back the tasks they most wanted AI for. The pay went from $150 an hour down to $50, which changed who was still willing to sign up. And for developers running several agents at once, the reported timings stopped being reliable at all. Every one of those pushes the same way. They do not erase the number. They bend it downward, which is why METR calls it a lower bound. Before starting, the developers in the first study predicted AI would make them 24% faster on this work. Afterwards, having done the work, they still believed they had been sped up by about 20%. The measured result went the other way. Those tasks took 19% longer with AI than they did without it. A year later, the same measurement crossed zero, from 19% slower in 2025 to 18% faster for the 10 who came back. But an estimate arrives with a range around it, and this one runs from 38% faster to 9% slower. It contains zero. The honest reading of that interval is that the effect could still be nothing at all. 10 developers came back from the original study, and the 18% figure comes from them alone. 2% developers were recruited fresh, and their estimate is 4% faster, with a range that also contains zero. Here is the fair version of the counter-argument, and it comes from METR. They label the 2025 result out of date on the page itself. They also say developers are likely more sped up now, and that their own data is only very weak evidence for how much. One of the most widely quoted 2026 figures on review time comes from Pharos AI, a company that sells engineering analytics. That does not make the figures false. It means the method and the publisher are part of the number, and you check both. Disclosure is not disproof. A vendor with telemetry from 22,000 developers may well have the best data anyone has on this. So the next time a productivity figure lands in your planning meeting, there are a few things on the receipt worth asking for. What was the control group, and who quietly stopped volunteering for it? That second question is where the bias hides. And what is the range around the number? If it contains zero, you have a direction to explore, not a size to plan with. And when developers will not give up a tool even to help measure it, that refusal tells you something. Not the size of the effect, just which way the number leans.